The National Electrical Code specifies that the maximum length of SO cord that is permitted for use with a 480-volt 36-inch fan is 25 feet. This measurement considers the total length of the cord, encompassing the portion extending from the fan up to the ceiling as well as the segment running from the ceiling to the electrical outlet. In an industrial setting, it is generally recommended to replace SO cord with conduit for enhanced safety and durability. Conduit offers superior protection against various environmental factors such as physical damage, moisture, and exposure to chemicals, all of which are commonly encountered in industrial environments. There are several reasons for this recommendation. Firstly, durability. Conduit is more robust and can better withstand the demanding conditions found in industrial settings, providing a longer lifespan for the electrical wiring system. Secondly, safety. Conduit creates a secure and protected pathway for electrical wires, significantly reducing the risk of electrical hazards such as shocks, fires, and equipment malfunctions. Thirdly, code compliance. Certain jurisdictions may mandate the use of conduit in industrial settings to comply with local electrical codes and regulations, ensuring a safe and standardized electrical system. When replacing SO cord with conduit, it is crucial to adhere to proper electrical installation practices to ensure safety and functionality. Firstly, select conduit that is appropriately rated for the voltage and current requirements of the fan, ensuring it can handle the electrical load without overheating or failing. Secondly, securely fasten the conduit using clamps or straps to prevent movement or damage, maintaining a stable and protected wiring pathway. Thirdly, carefully pull the wires through the conduit, avoiding any sharp bends or kinks that could damage the insulation and compromise electrical safety. Fourthly, connect the wires to the fan and the outlet following the manufacturer's instructions and adhering to all applicable electrical codes, ensuring a proper and reliable electrical connection. Fifthly, label the conduit clearly, indicating the voltage and any other relevant information such as the circuit number or the fan's identification to facilitate future maintenance and troubleshooting. In addition to these installation practices, consider a few additional factors. Firstly, ensure that the fan is securely mounted to the ceiling, using appropriate hardware and installation techniques to prevent it from falling and causing injury or damage. Secondly, regularly inspect the fan and the cord for any signs of damage or wear, such as frayed wires, cracked insulation, or loose connections, addressing any issues promptly to maintain safety and prevent further damage. Thirdly, follow all manufacturer's instructions for the safe operation and maintenance of the fan, including recommended cleaning procedures, lubrication schedules, and any other specific guidelines provided to ensure optimal performance and longevity. It is also crucial to understand the relevant sections of the National Electrical Code pertaining to flexible cords and conduit installations. Firstly, NEC Section 400 covers the use, construction, and opacity of flexible cords and cables, providing specific requirements for different types of cords and their applications. Secondly, NEC Section 300 addresses wiring methods and materials, outlining the general requirements for installing electrical wiring in various environments, including industrial settings. Thirdly, NEC Section 344 covers the requirements for rigid metal conduit, specifying the types of materials, installation methods, and support requirements for this type of conduit. Fourthly, NEC Section 348 addresses the requirements for flexible metal conduit, providing guidelines for its use, installation, and support in various applications. It is important to consult these sections of the NEC and any other applicable codes or regulations to ensure that the installation complies with all requirements and provides a safe and reliable electrical system. Remember that working with electricity can be dangerous, and it is always recommended to consult with a qualified electrician for any electrical work, especially in industrial settings where the risks are higher. A qualified electrician has the knowledge, skills, and experience to perform electrical installation safely and correctly, ensuring that the system meets all applicable codes and regulations. They can also identify any potential hazards and take steps to mitigate them, protecting workers and equipment from electrical accidents. When selecting an electrician, it is important to choose one who is licensed, insured, and experienced in industrial electrical work. Ask for references and check their qualifications to ensure that they are competent and reliable. A reputable electrician will be able to provide you with a detailed estimate of the cost of the work and will be able to answer any questions you have about the installation process. Investing in a professional electrical installation is a wise decision that can save you time, money, and potential headaches in the long run. It ensures that the electrical system is installed correctly and safely, reducing the risk of electrical problems and accidents. It also provides peace of mind knowing that the work has been done by a qualified professional who stands behind their work. Consider also the specific requirements of the 480-volt 36-inch fan you are working with. Firstly, check the fan's nameplate for the voltage, current, and horsepower ratings, as well as any specific instructions or warnings from the manufacturer. Secondly, ensure that the electrical circuit supplying the fan is adequately sized to handle the fan's current draw, using the appropriate wire gauge and circuit breaker or fuse to prevent overloading and potential hazards. Thirdly, consider the environmental conditions in the area where the fan is installed, such as temperature, humidity, and the presence of any corrosive substances, selecting conduit and wiring materials that are suitable for these conditions. Fourthly, implement a regular maintenance program for the fan, including cleaning, lubrication, and inspection to ensure that it operates efficiently and safely over its lifespan. By carefully considering these factors and following all applicable codes and regulations, you can ensure that the 480-volt 36-inch fan is installed and operated safely and reliably in an industrial setting. Remember that safety should always be the top priority when working with electricity, and it is always best to err on the side of caution. If you have any doubts or concerns, consult with a qualified electrician or electrical engineer for guidance and assistance. Additionally, consider the potential for energy savings by using a more efficient fan motor or by implementing a variable frequency drive to control the fan speed based on the actual cooling needs of the area. This can reduce energy consumption and lower operating costs over the long term. Furthermore, investigate the availability of any rebates or incentives from your local utility company or government agencies for energy-efficient equipment or upgrades. These programs can help offset the cost of the new equipment and make it more affordable. When selecting a replacement fan motor, look for one that is rated for premium efficiency, which typically meets or exceeds the NEMA premium efficiency standards. These motors are designed to operate more efficiently than standard motors, reducing energy losses and lowering operating costs. Also, consider the use of electronic overload protection for the fan motor, which can provide better protection against overloads and short circuits than traditional thermal overloads. Electronic overloads can also provide valuable information about the motor's performance, such as current, voltage, and power factor, which can help identify potential problems early on. In addition to the electrical considerations, it is also important to address any mechanical issues with the fan, such as worn bearings, loose blades, or unbalanced rotors. These problems can cause excessive vibration, noise, and energy consumption, and can eventually lead to premature failure of the fan. Regularly inspect the fan for any signs of mechanical problems and address them promptly to prevent further damage and ensure safe operation. When replacing the fan blades, be sure to use blades that are specifically designed for the fan motor and application. Using the wrong blades can reduce the fan's efficiency and increase energy consumption. Also, consider the use of a fan guard to protect workers from accidental contact with the rotating blades. Fan guards are required in many industrial settings to comply with safety regulations. Finally, document all electrical and mechanical work performed on the fan, including the date, description of the work, and the name of the person who performed the work. This documentation can be valuable for future maintenance and troubleshooting, and can also help demonstrate compliance with safety regulations. In summary, ensuring the safe and efficient operation of a 480-volt 36-inch fan in an industrial setting involves careful consideration of electrical codes, proper installation practices, regular maintenance, and attention to both electrical and mechanical aspects of the fan. By following these guidelines, you can minimize the risk of electrical hazards, improve energy efficiency, and extend the lifespan of the fan. Remember to always consult with qualified professionals for any electrical or mechanical work, and to prioritize safety above all else.